In this video, on section 8.1 to 8.3, we're going to take a look at the example problems. So the first one is find the area of the shaded region. So if we notice, we have a rectangle here, and the area of a rectangle is base times height, but we have some pieces missing. So we have this piece here, this is a parallelogram, and this piece here, this is a parallelogram. So what we have is, I like to kind of write these out. We have a rectangle minus 2 copies of the parallelogram. So for the rectangle, we're going to use the base times height formula, but we're also going to use that same formula for the parallelogram. For the rectangle, the base is 9 and the height is 13. For the parallelograms, the height is this distance here, which would be 9, and each of the bases are 2. And again, that's why we can multiply that by 2, because the parallelograms are congruent. And then we can just go ahead and compute that. So 117 minus, I'm sorry, this should not be a 13. That should be a 2. There we go. And it's 81 square centimeters. For this one here, we have a kite, and the area of a kite is 1/2 d1 times d2. So here's d1. It's 2 inches or 2 centimeters from here to here, and 8 from here to here. So that would be 10. And here is d2. It's 2 centimeters and then an additional 2. So that would be 4. Half of 10 is 5. And 5 times 4 is 20. For number 3, we know the area, and we're going to be solving for one of the bases. This is a trapezoid. So the area of a trapezoid is 1/2 the sum of the bases times the height. And we're going to set that equal to 126, and we're going to substitute in our one base, which is 16. And then the height is 9, right? So the height is the distance between the bases. The bases are the parallel sides. So there's a couple of different ways that we can solve this. We could distribute. I actually don't recommend it. If we simplify this side, it just takes more work. This is 9/2, right? 1/2 times 9. I hope you can read my writing here. It looks a little, to me, it looks a little sloppy. Okay, so first we're going to multiply by 2/9. That's the reciprocal of 9/2. And that's going to go ahead and simplify that. So we're left with the 16 plus b2. And that's 21. And then we can go ahead and subtract. And turns out b2 is 5 inches. And again, remember, these are easy to check. And the reason is because you can just go ahead and use the formula again. So if you go to 16 plus 5, that's 21. Multiply that by 9. And then that is not going to work now that I think about that. Let's go back and see where we made our mistake here. We did 9/2, 16 plus b2. We multiplied by 2/9. Oh, I apologize. This was 28. There we go. 28 minus 16 is 12. Okay, so see, there we go. I went to double check my answer, and it did not work. And that was a good thing. So then I was able to catch my error. So let's go back. So now if I add b2 is 12, 16 plus 12 is 28, times 9 is 252, divided by 2 is 126. So that works. Okay, for number 4. So this is kind of interesting. So we have a triangle, and it is a right triangle, triangle ABC, and AB is 6, and AC is 8. And we want to find segment AD. So segment AD is an altitude, right? It's from vertex A to side BC. And it's perpendicular to segment BC. So if we I just want to redraw this triangle for a second. Here is A, here is B, here is C, here is AD. So if we kind of redraw the triangle this way, we could actually find its area by multiplying this base times this height, which in this picture is the blue and the second blue segment. So to find the length of AD, what we're first going to have to do is find the area of triangle ABC, which is 1/2 BH. So it's 1/2 times 6 times 8. Half of 6 is 3, and 3 times 8 is 24 square centimeters. Now we know that the area of the triangle is going to be the same no matter which way we turn the triangle, or remember we could chop up the triangle and we could rearrange it. So if we calculate the area using segment AD and segment CB, because they're also like a base and a height because they're perpendicular, we should get the same area. And so that means 24 would be equal to 1/2 base height, which is 1/2 times, we know BC is 10, AD is the height, what we're looking for. Half of 10 is 5. And then if we divide both sides by 5, we don't really get a nice answer. I mean, it is a decimal. It's not too bad. So 24/5, which as a decimal is 4.8. So AD is 4.8 centimeters. Let's take a look at some application questions. Annabelle is starting a painting business this summer and is estimating how much she should charge for painting 148 hotel rooms with 1 coat of base paint and 1 coat of finishing paint. The 4 walls and ceilings of each room must be painted, and the room measures 14 by 16 by 10. So the 14 and the 16, if we think about a room, I'm going to draw like this wall coming out and this wall going sideways. And think about like the rest of the room will be this way. So this could be like the back wall. So one of these walls is 14, one of these walls is 16, and it's 10 feet high. And we want to paint that. So this is the wall 1, right? But there's 2 of those. So we're going to multiply that by 2. This is wall 2, but there's 2 of those. So wall 1, wall 2, and then of course we need the ceiling. So the ceiling, right, would be the same as the floor. So that's going to be the green. That's going to be the 14 by 16. All of these are rectangles, so they're going to be base times height. So wall 1, the area is base times height. So we're going to multiply 2, because again, we need 2 of those. And this is 10 by 14. So that's 280 for both of those walls, square feet. Wall 2 is also 10 high and 16. So again, wall 2's area is base times height. We have 2 of those. That should be 320. And then the ceiling, there's 1. Remember, we're not painting the floor, we're just painting the ceiling. The ceiling is 14 by 16. And so if we look at the total there, that would be 224. So the total would be adding all those up, 824 square feet. That's for one room. And then, of course, we have 148 total rooms. And so that means we would need 121,952 total square feet of paint. So base paint covers 500 square feet. So to get the total amount of gallons, we take the total area and we divide it by the coverage of 1 gallon. Now I have a feeling this isn't going to go in perfectly. So we're going to have to round our answer. So we end up with 243.9, which means we want to round up to 244 gallons because we want to have too much rather than not enough. And then for the finishing paint, same idea, total area divided by, that's a 5, coverage of 1, and we get 487.8, which is about 488 gallons. So in other words, we just doubled this one, but I wanted to make sure. Sometimes it doesn't work out. If this would have been, maybe 486, we could have not had to have 488. Okay, and our last one is we have a landscaping architect business. We have 3 trapezoidal flower beds around 3 sides of a hexagon. The area of the flower beds, what is the area of entire flower beds? So if we have 1 here, okay, so the height is 7 feet. You can see this little distance here is marked off at 7. One of the bases is 12 because it's the side of the hexagon, and then the other base is 20. So it says, what is the area of entire flower bed? So the area of 1 trapezoid is 1/2 B1 plus B2 times height, and then we have 3 of them. So 12 plus 20 times 7. So it's 3 times half of 32 times 7. So each one is 112, and we have 3 of them. Which is 336 square feet. Yes. The fee is $100 plus $5 per square foot. So the total cost is the $100 fee plus $5 times the total amount of square feet. Which would be a total of $1,780. Okay, so this concludes section 8.1 to 8.3, looking at area of quadrilaterals, triangles, and then some applications.